Hello students, today we will be solving the numericals based on the concept of electric charges and fields. So the first problem states that two equal charges are placed at a separation of 1 meter. What should be the magnitude of the charges so that the force between them equals the weight of a 50 kg person? So for this, let us just put down the data. Now the data has been given that Q1 and Q2 are charges of equal magnitude. So for simplicity's sake, I am going to put them as Q1 equals to Q2 equals to Q. Okay. And we have been given that there is a person of mass 50 kg and the distance of separation between the two charges has been given as 1 meter. Okay. And the condition given is that the electrostatic force, that is F electrostatic, is equal to the weight of the person. I'll just put it as Fw. Now according to the Coulomb's law, we already know that F electrostatic is given as 1 by 4 pi epsilon naught Q1 Q2 by R12 square, and this is equal to m into g. Now this we already know that 1 by 4 pi epsilon naught is 9 into 10 raised to 9 into Q1 and Q2 both are equal charges, and we have given that Q1 equals to Q2 equals to Q. So I'll just put it as Q square whole divided by R12 square is nothing but 1 square, and this is equal to 50, that is mass is 50 kg into G value is 9.8. So 50 into 9.8 is nothing but 490 Newton. So now Q square will be equal to, I'll just cross multiply. So this will be 490 divided by 9 into 10 raised to 9. So now this I can write it as Q equals to square root of 490 divided by 9 into 10 raised to 9, which gives me a value of 233 into 10 raised to minus 6 coulomb. That is, when I have two charges of 236 microcoulomb, I can have the force, electrostatic force between the two charges, two equal charges, that is these two equal charges being equal to 490 Newton, that is, which is nothing but the weight of the person. Okay. So this is about your first problem. Now let us continue to the next one. So the next problem, it states that two charges, 2 into 10 raised to minus 6 coulomb and 1 into 10 raised to minus 6 coulomb are placed at a separation of 10 centimeter. Locate the position where a third charge will not experience a net force. Okay. So for this, we have two charges. One is, first charge is Q1 is equal to 2 into 10 raised to minus 6, that is 2 microcoulomb. And Q2 is taken as 1 into 10 raised to minus 6 coulomb, which is 1 microcoulomb. And there is one more charge which we have to place between these two, which I am going to take it as Q, Q3 equals to Q. Now remember one thing, the Q1 and Q2 both are positive charges. So if I am going to take this Q3 also as plus Q, then the Q3 is going to experience a force due to the first charge, that is Q1, in this direction, which I am going to call it as F A, because the Q1 is placed at A, I am going to call it as FA, which is acting in the direction OB, and the force on Q, that is Q3, due to the charge at B, that is Q2, will be in this direction. So I am going to put it as FB. Okay. So the two forces, as you can see, they are at 180 degrees to one another. Now, the main reason why we are actually solving this problem is to find this position X. So we have to find this position X, which from this charge 2 microcoulomb, in such a way that the Q3 is not going to experience any kind of net force. That is, the given condition is that the magnitude of FA bar should be equal to magnitude of FB bar. In such a case, what happens is, the forces FA bar and FB bar both are going to get cancelled out because they both have the same magnitude. but they are in opposite directions, so they will cancel out. So net force acting on Q3 should be equal to 0 in such a case. So we are going to make use of this particular condition which has been given, that is the equilibrium condition, to find out what is the distance x. So let us put down the data. So the data is Q1 equals to 2 microcoulomb, Q2 equals to 1 microcoulomb, D12 equals to 10 centimeter, that is 0.1 meter, and Q3 equals to Q, and R13, that is the distance from A to O, it is taken as x meter, and R23 is taken as 0.1 minus x. So now we'll apply the condition, that is FA is equal to FB. Okay, so FA is equal to FB, that is magnitude of FA is equal to magnitude of FB. So I'll just put down the formula according to the Coulomb's law. So this will be 1 by 4 pi epsilon naught into Q1 into Q divided by R13 square, and this should be equal to 1 by 4 pi epsilon naught into Q2 into Q3, sorry, this is Q2, this is Q2 into Q divided by R23 square. I can see that Q and Q gets cancelled, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught gets cancelled. So we have Q1 by Q2 is equal to R13 square divided by R23 square. So this implies we have 2 into 10 raised to minus 6 divided by 1 into 10 raised to minus 6 equal to x square divided by 0.1 minus x the whole square, right? So let us make a bifurcation. Now we'll start off here. So you can see that 10 power minus 6, 10 power minus 6 gets cancelled. So we have x square divided by 0.1 minus x whole square is equal to 2. I'll take the square root over here on both the sides. So the left hand side becomes x divided by 0.1 minus x equals to square root of 2 is 1.41. I'll just ignore the rest of the terms. So it will be x divided by 0.1 minus x equals to 1.41. So now we have x equals to 1.41 into 0.1 minus x. The x will be equals to 1.41. Just a moment. I have to multiply this. So this will be 0.141 minus 1.41x. So I'll take this 1.41x to the other side. So it becomes 2.41x is equal to 0.141. So x will be equals to 0.141 divided by 2.41x. So sorry, this is 2.41. So this will be equal to, the value turns out to be 0.141 divided by 2.41 is equal to 0.059 meter. Okay, so the value is 0.059 meter, that is at a distance of x equals to 0.059 meter, if you are going to place this charge q, then it is going to experience a net force equal to 0. That is, the two forces are going to cancel out, and obviously there will be no net force acting on the charge q. Now let's start with the third numerical. So in the third numerical, we have three identical point charges plus 2 microcoulomb each are placed at the three corners A, B and C respectively of a square ABCD of side 0.1 meter. Calculate the resultant force acting on the charge at B. So in this, firstly what we have to do is, we have to first find out the two forces, that is force on B, force on plus 2 microcoulomb charge which is at B due to the charge 2 microcoulomb which is placed at A. That is, the force will be acting along AB and extended In a similar manner, we also find out what is Fc, which is the force acting on the charge at B due to the charge at C. It is once again in the vertically downward direction. And then what we do is, after knowing the values of Fa and Fc, we'll take the resultant force of these two to find out what is the net force acting at the charge on B. Okay. So for this, firstly, we have to find out what is the force Fa. So Fa is equal to 1 by 4 pi epsilon naught into, we already know that it is Qa into Qb divided by Rab square. So this will be 9 into 10 raised to 9 into 2 into 10 raised to minus 6 into 2 into 10 raised to minus 6 divided by 0.1 the whole square. Okay, so on solving this, we get the force to be equal to 3.6 Newton. Okay, and similarly, since the distance between AB and distance between BC both are same, and also the charges A and C are also going to be the same, so we can safely say that Fc, which is equal to 1 by 4 pi epsilon naught into Qa into Qc divided by R is this is Qc into Qb divided by R Cb square is equal to 9 into 10 raised to 9 into 2 into 10 raised to minus 6 into 2 into 10 raised to minus 6 divided by 0.1 whole square. We can see that this is also equal to 3.6 Newton. Now we can simply find out the resultant force, that is F net, using the relation F net equals to square root of Fa square plus Fc square plus 2Fa Fc into cos of theta. Now here theta is equal to 90 degree. The reason is between Fa and Fc the angle is 90 degree. So I have substituted here. So the net force will be, since this is cos 90, so this entire term is going to be equal to 0. So we are left with only square root of Fa square plus Fc square. So this will be equal to square root of 3.6 square plus 3.6 the square. So this will be nothing but 3.6 square root of 2. So F net, that is the net force acting at point B or acting on the charge at B, will be equal to 5.09 Newton. Okay, so this is about your net force acting on the point on the charge of 2 microcoulomb which is placed at B. Now we also have to find out what is the angle. So to find the angle, we can simply say that the angle is alpha between AB and the net force, that is with regards to the force Fa bar, the angle is alpha. In such a case, we can see that the alpha, that is the angle, is given as alpha equals to tan inverse of Fc divided by Fa. So this will be equal to tan inverse of 3.6 divided by 3.6, which is equal to tan inverse of 1. So tan inverse of 1 is nothing but 45 degree. So the net force is nothing but the 5.09 Newton. Okay. So here what is happening is a force of 5.09 Newton is acting on charge at B, making an angle of 45 degree with the AB. Okay, so this is how we solve for such kind of problems.